Welcome. This video covers creating new variables using the dplyr package. Now, the idea of creating a new variable that we're going to look at here is creating a new variable that's a function of the previous variables that you already have in your data set. So we talked about this idea that maybe we want to create an age type variable that will be a function of the actual age of the pet, whether it's indoor and outdoor, and then what type of pet, since different types of pets live different ages. How do we do that and stay in the tidyverse framework? Well, let's start with a data set. We will read in this data set on movie ratings. It's called Fandango, and it comes from the 538 library. So again, this is a package. You would need to install this package if you've not installed it already. Recall, installing is just downloading the files to your computer. Library is then gaining access to them within your particular session. So this Fandango data set here, it's a tibble. So 538, this package already has tibbles in it. They like the tidyverse there. And so this has 146 rows and 23 columns. Okay. Well, how do we add variables to this data frame? How do I create a new one and put it on this data frame? Well, the mutate function allows us to do that. Here's the syntax for using this mutate function. All you need to do is give it the tibble that you want to work on, and then you can specify as many variables as you want to create that are functions of the data. You give the name of that variable on the left-hand side. So, for instance, there are two different Rotten Tomatoes scores in this data set. There's a regular Rotten Tomatoes score and then a Rotten Tomatoes user score. So this is the critics score, I believe, and then this is the user score. Perhaps what we want is just one summary measure about the Rotten Tomatoes score on these movies. And so what we're going to do is just take the average of those two scores and create a new variable. Okay, well, we'll use our chaining. We'll say take the Fandango data set and then mutate or add a variable called average rotten. That's the sum of the Rotten Tomatoes score and the Rotten Tomatoes user score divided by 2. And that will create a new variable on this data set. And in fact, you can see it down here as the last variable on this tibble. Now, one thing to note is that this does not overwrite the data frame itself. So this is not sort of replacing the Fandango data set unless you explicitly overwrite that object. So we have created this tibble with this extra variable in it, but we have not saved it anywhere. So we have lost this new variable, basically. If I wanted to keep that thing, I would need to save this as a new object or perhaps overwrite my original Fandango object itself. Now, if we wanted to be able to see the variable just to sort of check and make sure it worked, remember that we have this functionality from select that will allow us to reorder the columns. I'll do the same function call here to mutate, create that variable, but then I'll use my chaining to say then with the result of that, select the film, year, average rotten, and then put every other variable in the data set after that. And so now you can see I see the film, the year, the variable that we created, and then the rest of the variables in the data set. And this allows us to see that, this does look like it worked correctly, right? The average of those two values is 80. So that's good to see. Again, you don't need to just add one variable using this mutate function. You can add as many variables as you want. You just separate them with commas. So we'll do the same thing with the Metacritic score. So there's a normed score for the critics and then a user score as well. And what we're going to do is we're going to create a new variable called average meta that's equal to the average of those. We'll do the same select function call so that we can see both of these two new variables that we created, and we see them here in this data set. Now, mutate can also take in statistical functions, so it doesn't need to just be a straight function of the other values within that particular row. Instead, what we can do is utilize functions like mean or standard deviation, which are just built-in functions to find summary statistics in R. And what we're going to do here is just add a column that's all of the same values for these variables. So I'm going to take the mean of the Rotten Tomatoes score from this Fandango data set. I'm going to add that as a column called AVG or average. Similarly, I'm going to create the standard deviation of the Rotten Tomatoes column, and I'm going to add that as a column here. So this is the same value for every observation. Now, where this comes really in handy is if you want to add in, say, grouped means and group standard deviations, those kinds of things. The dplyr package has a really nice function called group by. And this group by allows you to create summaries for groups or by groups. And all you need to do is take your data set. So I'm going to take Fandango, then select just two variables so we can just see what's going on. And then I can do this group by function call. So then I'll group the result of that by year. What that does is it adds a little attribute to your tibble that says, hey, there are groups now associated with this thing. All of the functions within dplyr then that do summaries, like the mutate function whenever I call that, I'm going to do a summary. When I go to do summaries on this tibble, they will now respect that grouping. So when I do mean of Rotten Tomatoes, it's actually going to do the mean of the Rotten Tomatoes by year. When I do standard deviation of the Rotten Tomatoes, it's actually going to do standard deviation of that column by the year setting. So again, this is going to be common across the use of dplyr functions. We're going to look at the use of the summarize function to do summaries of data in a little bit. And so we'll use group by and then summarize to just create a tibble that just has those summaries by groups. But this is a way to create those summaries by groups, but also add them to your data frame or tibble. All right, the other major way that we will look at creating variables is through conditional execution of code, i.e. using like if then else ideas. So you may have been exposed to this somewhere else. If not, we'll try to walk you through it. But the idea is that I want to put up some logical condition, and if that condition is true, I want to execute a certain set of code. If that condition is false, I want to execute a different set of code. And so the if-else function, if_else function from dplyr, is a vectorized version of this conditional execution. This is the syntax for using it. I give it a condition, so a vector of true false values, just like we did when we were filtering or subsetting our rows. And anywhere that returned a true, this code gets executed. And anywhere that returned a false, this code gets executed. So whatever code we put in those different spots. And what it does is it just returns a vector corresponding to those conditional executions. Let's see how to use this thing in practice. Let's just consider a built-in data set called air quality. This, by being built in, I just mean it comes preloaded whenever you open up base R. So you don't have to read it in from a package or from an outside source. And this gives us daily air quality measurements in New York City from like 1973. We'll first coerce that thing to a tibble. So we'll use the as_tibble function to create a new R object called my air quality. That is a tibbled version of that. And so we can see it has measurements on ozone, solar radiation, etc., etc. And so what we might want to do is say, take a look at this wind variable. This wind variable takes on a number of different values. Maybe I want to categorize that thing. So I want to create a wind category variable. I happen to know or happen to want to make any windy day that had a wind of 15 miles per hour or greater. I want to make that a high wind day. Any that were between 10 and 15, a windy day, 6 and 10, a light wind, and less than 6, a calm day. So this is the exact kind of idea where if then else logic can come into play. If this condition is met, I want to label it as high wind. If this condition is met, I want to label it as windy, right? So I'm doing an if this, execute that. Else, maybe execute something else. So here would be an example of using if_else without sort of using the tidyverse notation. So we'll see how to bring it into tidyverse here in just a second. But remember what if else does. The first argument is a vector of conditions, right? So this is a vector of true false values. And so we're just doing a logical comparison here, right? We're taking from my air quality, we're taking the wind vector. So this is the entire column returned as a vector. And we're comparing that whether it's greater than or equal to 15. So each individual element gets compared to 15 and a true or false value gets returned. Anywhere a true value is returned, we assign high wind. So if true, we're taking on the value of high wind. The next argument after this comma is what happens if that argument was false, if that logical statement resolved as false for that entry. Well, we could say return whatever we wanted here, but really what we want to do is another conditional check to say, well, if it's now greater than or equal to 10, I want to say it's windy. So what we can do is just put in another if-else statement at this point. So if that first one resolved as false, I want to say, well, if else, so check again, take my air quality $wind, get that vector of comparisons with 10 now, and if that one returns true, give me windy. But if that one returns false, let's go ahead and check if it's greater than or equal to 6. If that's true, give me light wind. If that's not true, then all of these other statements must have been false already. And so this one's false too, would then return calm. So that should give me everything that's from 0 to 6 returned as calm. And so that's the idea with conditional execution. We can do a condition, check that. If it's true, execute one bit of statement, one bit of R code. If it's false, execute another. And so here is how we might bring this into the sort of tidyverse way of coding. So we're going to say, let's overwrite my air quality, that object, with a new object that takes the original air quality data set and then mutates or adds a variable, right? We just looked at mutate. We're going to add a variable to that data frame, and that new variable is going to be called status. How do we create that status? Well, we're going to use this if-else logic that we just saw on the previous page. The only difference is that now I don't need to put this $business with the data set first, because since we're working in this kind of situation, it knows that we're working with the my air quality data set. So it allows us to simplify our syntax a little bit. But this will go ahead and create a status variable that corresponds to our win categories. Fantastic. All right, let's jump into R and do some variable manipulations and create some new variables using dplyr. All right, here we are in R. Let's go ahead and create some new variables. First thing, we are dealing with this my wine data set, so let's just remind ourselves what variables that has in it. So my wine data had a number of variables measured on some wines, and we can see that there's a number of things that sort of are related to each other. So there's free sulfur dioxide, total sulfur dioxide, a few other things that are related as well. So maybe we could create a new variable that's the difference between the free and total sulfur dioxide, for instance. So let's take the my wine data, and then we will create a new variable using mutate. So we'll say mutate, create a new variable and add it to this data frame. This new one's going to be called fixed. I don't know if that's actually a thing, but fixed sulfur dioxide. So it'll be the difference between total and free. I don't know if that's an actual thing. So we'll do total sulfur dioxide minus free sulfur dioxide. And that should create a new variable for us. Remember that that's going to get appended on the end of the data set. So let's go ahead and, sorry, caps lock. Let's go ahead and select that variable as the first one so we can see it. And then we'll put everything else afterward. Let's run that code. All right, now we have a free sulfur dioxide variable corresponding to that. So there's some code to create a new variable and add it to our tibble. Again, this does not overwrite the my wine data. So even though we've added it to it, we've done the computation, it's printed it out, but we sort of lose access to that variable unless we save this as a new object or overwrite the original object that we had. And let's add another variable. Rather than using the if_else function like we did before, there's actually a function from base R called cut that can be used for a similar type of creation of a variable. So what it allows you to do is divide the range of x, where x is some numeric vector, into intervals, and then codes the values according to which interval they fall. So it's essentially a shorthand function for doing that if_else that we just did. And so what we need to supply this cut function is x, the numeric vector, and then breaks. And breaks is either a numeric vector of 2 or more unique cut points, or a single number giving the number of intervals to split x into. So we'll do it with specifying what exactly the endpoints should be. And so we can create a second variable using mutate. Remember, we just separate them with commas. So in this case, I'm going to create a second variable that's the categorized fixed acidity. A great variable name, nice and long. And so we're going to use the cut function to define this thing, and we're going to give it the fixed acidity variable as the x that we're going to break up. And then we're going to specify what breaks we want to use on that thing. And so remember, this either needs to be a numeric vector of 2 or more cut points. So we know how to create a vector with C, so 2 or more cut points, or a single number giving the number of intervals to cut it into. So we'll give it the unique cut points. So we'll say, let's start at 0. We'll say 4, 7, 10. Let's go all the way up to 16. Is that the largest acidity you can have, I think. And then that will create our new variable corresponding to that. To be able to see it, let's go ahead and pull that in as well. Categorized. Great name again, acidity, and then everything. Let's run that. And we can see now that that second variable corresponds to a categorized fixed acidity, where you can see that this means that it fell into category 7 to 10. This one fell into category 10 to 16. And what's kind of odd is this is something we haven't really investigated yet. This is called a factor variable. So factor variables are like categorical or character variables, except that there are only certain values that that variable can take on. And so there's a fixed number of what are called levels that that thing can be. but you can edit the levels. You just can't assign that variable to anything other than one of its levels. So let's go ahead and overwrite the data set at this point. And this does mess around with our spacing. Oh, no, it doesn't. Okay, so we'll go ahead and overwrite the mywine data with these two new variables. And then let's just investigate this factor a little bit more. And so we will pop in a new code chunk. All right, we'll look at the structure of this particular variable. So we got the mywine data, $, categorized fixed acidity. If we run that, we can see that this is a factor variable with 4 levels. And levels is actually a function in R. So if you can look at the levels of any category of any factor variable. So mywine data, categorized fixed acidity. And so the levels are the unique categories that this variable can actually take on. So it's going to fall into one of these: 0 to 4, 4 to 7, 7 to 10, 10 to 16. These are just the labels for the categories. And what's kind of nice is that you can actually relabel these as you wish. So you can do an assignment on the levels. So I can say the levels of mywine, I want to store a new character vector. And so I can overwrite these 4 values. So this will be least acidic, mildly acidic. Wait, is acidic towards 16 or towards 0? I don't remember, but we'll go with it anyway. So we'll just give it some different names here. Very acidic. And now if we look at this variable, and we look at the levels of it, we will see that they have been changed. And now when I look at it within my data set, it comes out looking a lot nicer. Now I have a nice categorical variable categorized with those names. So when I go to do plotting later on, this is going to be a nice way to deal with plotting variables. All right, so we have this mutate function, which is great for adding a new variable to a tibble that we already have. And we can use the group by function with that mutate to get summaries by different groups and add those variables to our data set. We also saw the if-else function for using conditional logic to create a new variable, and how that cut function can be used as well. The dplyr cheat sheet does give a lot of handy tips and tricks for using the mutate function and which kinds of functions you can use to create new variables.